turn around.
Okay, like
Since
Oh, I kind of did that.
What's that?
You're going to It's max. What happens to the size of the fraction and the number stays the same, but it's so funny. Denominator, I mean, 500. Got it. Look at the board here. Yes, it's right.
I asked her to start talking.
Okay. The size of the fraction and the number stays the same, but the fraction, but the thingy-mabob, it gets smaller. Example. Yeah, you divide 1/3, 1/4, and then it'll get. I wrote the word. Operation. What operation is this one?
Took a little long, but thank you for getting quiet. So I understand that your homework was a little bit challenging. Yes? Maybe. Some of them? Good. Which is why I wanted to start by going over it. So can we talk about the first one?
Yes.
All right, let's look at number 1. I heard some really, really good conversations. Some debates even. Some of you thinking some things, some of you thinking other things. So let's, first of all, did everybody see our funny cartoon on the board?
Yeah. No.
Vlada, can you read it for us?
To show how well I understand fractions, I only did half of my homework.
Did that apply to any of you? Now you have a good excuse. All right, what's the first question? Eamon.
What happens to the size of the
Just a second, Eamon. All right, go ahead.
What happens to the size of the fraction when the numerator stays the same but the denominator increases? Why?
Okay, so let's have a look at this. What happens to the size of a fraction when the numerator stays the same? Let's pick 2. And the denominator increases. Let's pick 3. So what would another fraction be where the numerator stays the same but the denominator increases?
2/7.
And let's pick one more.
2.
Wait, me?
Sean, sorry.
2 ninths.
I'll pick you for the next one. All right, so what happened? Amy.
I think it's getting bigger because it's the whole. So if you're changing the whole, then the numerator stays the same. So the whole gets bigger. And
Okay.
that's the number, so it's getting bigger.
But remember that this is the portion that we're talking about. This is the fraction of the whole. So here, my fraction of the whole is really close to my whole. Think about on a number line when we talked about yesterday. Anybody have a different thought? I see what you're saying, but let's get some other thoughts. Brian.
So what I was doing is I thought of it kind of as a pizza, and if you split it into thirds, the pieces would be bigger. But then if you split it into ninths, the pieces would get smaller. So like the 2/3 is smaller, would be bigger than the 2/9.
Does that help?
Yes.
So he's talking about thirds of a pizza. Here we're talking about sevenths of a pizza. Here we're talking about ninths of a pizza, right? And this we're only talking about 2 slices. Here we're talking about 2 slices. Here we're talking about 2 slices. My number of slices doesn't change, but the size of my pieces do. Does that help?
Yeah.
That was a really good way to put it. Does everybody agree with Ryan?
Yes.
So what happens to the size of a fraction? It gets smaller. So looking at the other one, what's the question? What's the question? You all have it in front of you. Elise, what's the question?
What happens to the size of the fraction when the numerator increases and the denominator stays the same? Why?
All right. So what happens to the size of the fraction when the numerator increases and the denominator stays the same? So let's start maybe with 8 And we'll go with 2 again. Give me an example of a fraction where the numerator increases and the denominator stays the same.
5/8.
Yes. My numerator went up. My denominator stayed the same. One more.
8/8.
Sure. What is 8/8?
Oh.
Awesome. So what's happening to the size of my fraction here?
Biggie.
Ariana?
If you get it bigger, like it's going from 2/8, this isn't up there, and 5/8 gets bigger, and then it gets to the whole.
You got it. Can anybody explain what Ariana said in a different way? So we're saying, she's saying the fraction gets bigger. I'm agreeing because we're ending up with one whole here, which we know is sort of the biggest fraction we can have before going over into more than one whole, more than one. Well,
So, the 2/8 is basically like the, thing that, yeah. So, but then, you would add 3 more slices, and then you would add the other 3 more, so it's increasing the number of slices that, is missing.
Yeah. You know, I didn't even think, but I'm glad that I used this as an example because here we have a visual. Does everybody see what Will's saying? It's just more of the April Fool's gross, nasty pie that Mr. Reinauer made, right?
Pickle juice.
All right. So, yes. So, can we all agree that the fraction gets bigger? The size of the fraction gets bigger? Does anybody have any questions? If you don't have yours, look on somebody else. We're going to do one more, and then we're going to come back to this because I do have something fun for us to do today. And I know that most of you, the hardest were probably questions 4, 5, and 6, maybe, and 7. So what about...
Easy one.
Okay. What about number 3? What operation does the line in a fraction stand for? What operation does the line in a fraction stand for? Division.
Yes.
Division. There's no 2 ways about it. Division. Division. It means divide. Good. And we're going to come back to 4, 5, 6, and 7. So what you can do is not worry if it was tricky. I'm not surprised. I wanted to see what you guys already knew. And we're going to be going much deeper into fractions. And by the end of next week, those questions are going to seem easy for you. All right? So you can put those papers away and you can actually clear your desk. Throwing it on top of this binder. Did you do that? In the holes? In the holes. And then clear your desk.
I used to love
What I'm going to ask you to do, okay, is just explore for a minute. I'm going to give you 1 minute once you get your bag to just
play while I make food.
kind of play. A little bit.
Yes. And this. I don't know.
I feel like kindergarten.
Elise is ready, Ariana's ready, Christian's ready. Thank you, ma'am. Thank you, Amen. Hands away from your blocks. You don't need to put them away. No, that wasn't it. Okay, now I want you to turn on your fraction brain because this is not just about building and this isn't just about pattern blocks and this isn't really about geometry. This is about fractions. I'm just waiting for people to put their hands in their laps. Cool. This is about fractions. So now, as you explore with your fractions, there's no more building up. Everything needs to be flat on the desk. And you're not really building. What you're doing now is recording at least 5 observations about your pattern blocks in terms of fractions. So you should start to notice certain things.
I see what you
Okay? And I want you to record those observations. Max is ready to go. And you can then talk to your C partner about this.
Oh my gosh. These are really equal one.
I see lots of fractions of sets.
Hey, write this down. Okay. You want me to get you 5, 6, 7, 8.
Kaylin, do you have 4?
I have 4 of each.
Yeah.
5.
I mean, what are these? 5, 6, 7, 8. Wait, no.
Only put together to make one shape.
Okay, so the blocks might not always fit together to make shape. Gosh, Charlotte's. Okay, that's an observation. Ross is thinking fractions. I saw lots of fractions of sets going on.
I got a good one.
Christian?
I noticed that if like you said on for the just on this paper, that all the e's can equal up to the blue rhombus, the triangle, and the trapezoid all equal into one hexagon.
Oh. So how are you using fractions for that?
So I guess you would say like, but it would be like something like that, really.
So the smaller pieces are fractions of the yellow hexagon
Yeah.
whole?
All these pieces equal this.
Okay.
But they-
So Ryan, you had your hand up. Fraction of a whole, fraction of a set. How do you know?
Because she did it like she counted how many there were in the group,
Yes,
and then she saw how many different colors there were.
absolutely. So she's talking about in a group. Go ahead.
Like I got ways for like if you made like if for example you didn't have one of these, you could use 2 of these to make one of these.
Okay, so how does that relate to fractions?
It's like so like 1/3 of these would be 3/5 of these of 3/5 of a triangle. 2/5 of triangles would make one of these. So
Careful with 3/5. Why don't you figure out how many?
wait.
You're so close and you're so right. Why don't you take one of those red trapezoids? Everybody take a red trapezoid. Put it on top of the yellow hexagon.
That's
What
half of it.
fraction of the yellow hexagon is the red trapezoid? Everybody.
1/2.
That's where we're going. Nice, Ryan. Ah, it's not 2/6? I don't add the denominator, just the numerator.